Hello friends, let us now learn some important points about the factors affecting attenuation. So, in the factors affecting attenuation, there are four factors affecting the attenuation. The four factors determine the degree of attenuation of an X-ray beam as it passes through the matter. One of the factors involves the nature of radiation type, and the other factor and all the other three factors will involve the composition of matter. So the radiation, so the energy and density of matter, atomic number and electrons per gram of matter will affect the attenuation. Increasing the energy, radiation energy increases the number of transmitted photons, whereas increasing the density, atomic number and electrons decreases the number of transmitted photons. Increasing energy decreases attenuation and thus increases the transmitted photons, whereas increasing density, atomic number and electrons will increase the number of transmitted photons and thus it decreases the decreases the number of transmitted photons and thus increases the attenuation. We will learn about the relationships between density, atomic number, electrons per gram. So first we will examine each of the four sections that affect attenuation separately. But first we must digress the reviews the relationship between density, atomic number and electron per gram. First, density and atomic number. The relationship between density and atomic number is complex and there is no simple rule covers all situations. In general, a high atomic numbers elements with high atomic number have more density, except that there are two exceptions, that is gold and lead. Gold has atomic number of 79 and density is 19.3 gram per centimeter square, whereas lead has atomic number 82 and it has 11 gram per centimeter square. So then there is no relationship between the atomic number and density when different physical states of matter are involved. Water has an effective atomic number of 7.4 regardless of its state. So when normally density and atomic number, there is a relationship, but if different physical states of matter are involved, there is no relationship between the atomic number and density if different physical states are involved. So water has an effective atomic number of 7.4 regardless of ice, vapor or liquid, but its density is different in all the three forms. Then the next important thing is density and electrons per gram. Whenever a factor is expressed in units per gram, the concept of volume is eliminated. Density depends upon weight per unit volume. There is no relationship between the density and the electrons per gram, because 1 gram of water contains same number of electrons regardless of whether they are compressed together in 1 centimeter of 1 centimeter cube of liquid or spread over 1670 centimeters of centimeter cube of as a vapor. So the 1 gram of water will contain same number of electrons in ice or water vapor, that is in 1 centimeter cube of liquids or 1670 centimeter cube of vapor. So there is no relationship between the density and electrons per gram at all. So the next important thing is atomic number and electrons per gram. The number of electrons per gram is a function of number of neutrons in atom. Number of electrons per gram is really a function of number of neutrons in atom. If an element do not contain neutrons, all materials will have 6 into 10 to the power of 23 electrons per gram. If you see, hydrogen has 1 proton, 0 neutrons and 1 electron. So electron per gram of hydrogen which has no neutrons is 6 into 10 to the power of 23 electrons per gram, which is twice as many as any other elements. Whereas elements in soft tissues like carbon, nitrogen, oxygen all have equal number of protons and neutrons. So this should be halved. So this value of electron per gram will be halved to 3 into 10 to the power of 23 electrons per gram, and the higher atomic number elements will have even fewer electrons per gram because of increased number of neutrons. In general, lower atomic numbers have more electrons per gram when compared to higher atomic number. The next important topic is effects of energy and the atomic number. Effects of energy and atomic number is determined as a combination. So effects of energy and atomic number determine the percentage of each type of basic interaction. So in this sense, their effects on attenuation are inseparable. The percentage of photoelectric effects for various radiation energies of water, sodium and bone are different. So Campton percentage of Campton reactions can be separated by subtracting the percentage of photoelectric reactions from 100. So if you see this table, just let us draw this table, the important things. So if you see here, this is the table showing percentage of photoelectric reaction. So radiation energy, as the radiation energy increases, you can see the photoelectric effect of Campton reaction decreases. Similarly, the photoelectric effect as the radiation energy increases, photoelectric effect of water and compact bone decreases, and sodium iodide will a little increase. So the attenuation is photoelectric effect. Attenuation is a combination of all the three, that is photoelectric effect, Campton reaction and coherent scattering. Together we get the attenuation. Photoelectric effect shows the maximum attenuation. So we have given the photoelectric effect attenuation in this table. So with the help of this table, Campton reactions, percentage of Campton reactions can be calculated by subtracting the percentage of photoelectric reactions from 100. The percentage of photoelectric reactions for water bone increases as the atomic number increases. Water has an effective atomic number of 7.4. Compact bone has an effective atomic number of 13.8. So the photoelectric effect increases for water and bone as the atomic number increases, and the percentage of photoelectric effect has a percentage of photoelectric effect. So as the radiation energy increases, the percentage of photoelectric effect decreases. So photoelectric effect is directly proportional to atomic number cube, but it predominates at low energy radiation. As the energy increases, photoelectric effect decreases and Campton effect will increase, whereas coherent scattering is negligible. So as radiation energy increases, the photoelectric effect reactions for water and bone decreases, and as the atomic number increases from water to the compact bone to the sodium iodide, the percentage of photoelectric reactions increases, and at extremely low energy, that is at around 20 kilo electron volts, photoelectric effect predominates regardless of the atomic number of the absorber. As the radiation energy increases, the photoelectric effect decreases, meaning that the Campton scattering becomes more important until eventually the Campton scattering completely replaces the photoelectric effect, and Campton scattering becomes the predominant interaction. With high atomic number elements like sodium iodide, the photoelectric effect is predominant interaction even at higher atomic numbers. So throughout the diagnostic energy range, photoelectric effect is predominant, whereas coherent scattering will decrease. So we can say that the linear attenuation coefficient is the sum of the contributions from the coherent, Campton scattering and photoelectric reactions and Campton scattering. So linear attenuation coefficient mu is equal to the linear attenuation coefficient due to coherent scattering, linear attenuation coefficient due to photoelectric effect and linear attenuation coefficient due to Campton scattering. So by adding all of these three, we will get the linear attenuation coefficient. So these are the important points about the photoelectric. These are the important points about the relationship between density, atomic number, electrons and gram, electrons per gram. We have seen the relationship between three of them. In the next class, we will learn about the effect of energy, atomic number, density and electron per gram on the attenuation. Thank you.